Hi everyone, welcome back to Minerva Tutors TV. And today's lesson, mini beasts and bug houses, with our tutor Jack. So some of you may have seen Jack before in previous weeks. He's our chief science tutor here at Minerva Tutors, and he has been taking us on various scientific journeys. Today he's going to be introducing us to and teaching us a bit more about some of the weird, wonderful and essential little creatures that call our gardens home. And he'll also be showing you how you can build your own little house to invite them in your gardens. If you've got the equipment that we put on the list, you can follow along and build your bug house with Jack. You'll need some scissors as well, so if you're a younger viewer, make sure you've got an adult with you to help you use the scissors. So that's in addition to the equipment list we sent out before. If you haven't got everything you need, you can just watch Jack and he'll give all the instructions, and we will also send another email after the lesson confirming everything you need to do to build your own bug house. If you think of questions while the lesson's happening, if you could type them into the chat or just keep a record of them in your mind, there'll be an opportunity to ask Jack questions just before the end of the lesson. So it'd be really great to hear some of you and your questions later on. That's all I need to say to you this afternoon, so I will hand over to Jack.
Thank you very much for that introduction, Lawrence. Like you said, we're going to be looking at how to build a bug house today, but before we get into that, we're going to be looking at the types of things we find in our garden and the categories we can put those things down into. So first of all, we want to split. If we're looking at animals, we can split animals into two larger groups. We can split them into vertebrates and invertebrates. Vertebrates meaning they have a backbone, they've got a spine. And we actually fit into this group ourselves, vertebrates, because as you could probably feel in your own back, we have the spine or the spinal cord that keeps us sat upright and provides us structure. Now, there's a lot of other animals that fit into this section. One of those being us, of course, but we can split every other animal that fits into the vertebrate section into one of five categories. Those categories are mammals, birds, fish, amphibians, and reptiles. So we'll go through each one of those one by one and look how we can learn to put animals into one of these categories. So if we start off with mammals, we put an animal in the mammal category if it does these things here. If it gives birth to live young, so that's young that is alive when it's born, it's not in an egg form. They produce milk, they have fur, and they are warm-blooded as well. And warm-blooded just meaning like you and me, like dogs and cats, when you touch them, they feel warm to the touch. The blood inside them is warm. So examples that fit under this category are things like a panda, things like dogs and cats, even things like a platypus. Platypus is a bit of a weird example because it's got almost like a beak like you would expect a bird to have, but it fits into this mammal category. Another weird example of a mammal would be a bat, which has wings like a bird, but because it has fur, because it gives birth to live young, because it can produce milk, we put it in this mammal category. So that's category number one of the vertebrates, of the ones that have spines. Category number two is birds. So we can also classify animals as a bird. Birds tend to have wings, although there are animals that have wings that we don't classify as birds, but they tend to have wings. They also, instead of having fur, have feathers. So they're different to mammals in that way too. They've got feathers instead of fur. They tend to have holes for ears instead of ear flaps, like we've got animals as well, like dogs. You know, dogs have got flappy ears, and monkeys tend to have ears that are a bit closer to ours, but birds just have holes for ears. Birds also don't give birth to live young. They produce eggs, as we know, and those eggs will have quite a hard shell and will hatch into the babies eventually. So that's the second category we can have. We can have birds, and we've got things like penguins under that category, pigeons, ostriches, sparrows, all come under the bird category there. The third category of animals, category of vertebrates that we're going to be talking about is fish. So fish, again, different, as you can imagine, to mammals and birds. One big difference is that they breathe through gills rather than lungs. So birds and mammals, they breathe through using lungs, and we breathe using our lungs. We breathe in through our mouth, it goes into our lungs, and the oxygen that we breathe in diffuses into our bloodstream. Fish don't have lungs. They use gills where water passes through the gills, and they take the oxygen they need to breathe from the water itself through the gills. So that's one big difference. How you can identify that something's a fish is if it's got gills. Fins as well, because fish live in the water, they need to be able to move around and swim about, and they do this using the fins on the side and the fins on their tail as well, and above on top of the fish. Scales is another big difference between fish, birds, and mammals. Instead of having feathers, fur, things like that, they tend to have scales. So that's another group that we can put. And then the things that would fit into the fish group would be things like cod, things like sharks, salmon, if we're talking about bigger fish, like that. So all what we'd expect so far. The fourth group of vertebrates is reptiles. So reptiles are another quite interesting one, in that they, like fish are also this, they're cold-blooded. And when an animal is cold-blooded, instead of being warm-blooded like a bird or a mammal, when an animal is cold-blooded, they don't necessarily feel cold to the touch, but they rely a lot on getting their heat from the external environment, from the environment and the conditions around them. So for example, if a cold-blooded animal, like we've got snakes, we've got turtles, lizards, are at the wrong temperature in an environment that is the wrong temperature, they can't produce their own heat, their own body heat. So if they, for example, they're in a condition that was too cold, they would die more easily. So that's a disadvantage of them being cold-blooded there. The other thing with reptiles is they tend to live on land as well, and have scales, kind of like fish, but the scales are a little bit different this time. They tend to be a bit more rough, to add a bit more protection to these land-living creatures. Examples of reptiles, as you can see up here, we've spoken about a few already. We've got things like snakes, turtles, lizards, crocodiles would fit into this group as well, alligators, all would come under reptiles. So the fifth and final group of vertebrates, things with a spine, animals with a spine, that we can put animals into, are amphibians. And amphibians we tend to see more in the UK, sometimes, if we're lucky, see them in our garden as well. And that would be things like frogs and toads, if you're very, very lucky. But the way we can classify amphibians is they also tend to be sort of cold-blooded, but they are born with gills, kind of like a fish. So they start off more like the fish group and are born with gills to breathe through, and so sort of swim underwater. And an example of this is frogs. Frogs are born, they start off as frog spawn that turns into tadpoles, and tadpoles of course swim around in ponds and lakes. Eventually, as they grow up and grow up and grow up, they'll grow lungs and be able to move onto the land and act more like a reptile. So amphibians are interesting because they can often start off like they should be in the fish category and end up like they should be in the reptile category. And that's why they've got their own category. They tend to have webbed feet as well and be very, very good at swimming. And a few more examples of this: we've got the frog, we've got the salamander, which is like this sort of lizard-like looking thing over here. Although it's not a lizard, it's a salamander, and a newt as well. So yeah, we've got those 5 categories of vertebrates there, and I'll just pop them back up in the screen so you can see, and the key characteristics that each of them have. So remembering vertebrate, it's got a spinal cord or a spine in it. Now today, we're not likely, although we might find some types of bird, we might find, if we're lucky, some types of mammal in our garden, like squirrels, badgers, things like that. But we're not likely to be able to see many of these in our garden, especially compared to the other group we're looking today. So if we look on the other side of the group, and we said we've got vertebrates one side, invertebrates the other side. So if we go down the invertebrate route now, things that don't have a spinal cord, they don't have this spine to provide structure, we come to a category called arthropods on that side. Now arthropods make up 85% of every living animal ever discovered. And things that go into the arthropod category, they're cold-blooded, they have a segmented body. So like you can see here, we've got some sort of a beetle on the far side, we've got a spider here. So the segmented body we mean that the body is split up into segments. So it's got the head quite clearly, and you can see it on the spider the best, I think, at the top. You can see it's quite clearly separate to the body, which is below, or the thorax, the abdomen, which makes up this middle section of the spider there, and the thorax just below that, which is the third section. So it's almost like you're making a snowman, where you've got the head, you've got the body, and you've got the big ball of the legs, I would suppose, of the snowman at the bottom, where it's split up into those three categories. So that's what we mean by a segmented body, and all arthropods we should find have some sort of segmenting to their body. They normally have four or more, or over four, jointed legs. So they've got over four legs or limbs, because those legs / limbs can be claws or pincers as well that we're counting in this. But they've got more than four of them. And by jointed, we mean they've got joints in them, kind of like an elbow joint or a knee joint, so that they can bend them in the middle. The other thing that arthropods have, because they don't have a backbone, because they're invertebrates, of course, they have an exoskeleton. So they've got a hard outer coating that offers some protection if they were to fall, or if a predator, something that wants to eat them, was coming to get them, it would offer some sort of a protection against the predator as well. So it's kind of an alternative, this exoskeleton, an alternative to the spine that helps protect us and provide structure for us. The exoskeleton is doing a very, very similar type of thing there. So when we're talking about the arthropods that we find in our garden, we're going to talk about four very, very common ones that we're going to find today. So I'll get those up on the screen now, and you'll be able to see the four we're going to talk about. So I'm going to shift myself out the way slightly of these ones. There we go, that's a bit better. But what we can see is we've got these four. We're going to start off with this one here. Now this one here is a centipede, not to be confused with a millipede, which often looks very, very similar. But a centipede is made up of a long body that's segmented, again, segmented body. And on each segment, it has two legs. Now, centipede itself, there's a big myth and a big rumor that goes around that centipedes have 100 legs. Now, this isn't quite true. The reason people think it has 100 legs is because the name centipede in Latin actually means 100 legs. But in actual fact, they tend to have between 30 to 60, 15 to 30 pairs of legs, which means 30 to 60 legs in total. So it's not quite 100, although it is a lot, and you can sort of excuse the name and why they've rounded up with that one. So centipedes themselves, like this one, they can be anywhere between only a few inches long. They're the types that you might be more likely to find in your garden, or even they can be up to about 11 inches long, about this long. You'd be more likely to find those in rainforest environments. The types we'll find in our garden also will be sort of this browny color, maybe sometimes an orangey color. In the rainforest, the bigger ones, they can be really bright yellows, really bright reds colors as well. And that's simply a warning to anything that's going to eat it, because the warning is that centipedes can carry a toxin or a venom that makes them poisonous to eat. Now, the ones in the UK, we've got nothing really to worry about. They're not going to be poisonous or toxic to humans, but there are some that you would find in rainforests and closer to the equator in countries like Brazil, that would be dangerous to humans and dangerous to go and touch. But anything in the UK here is going to be pretty much fine to be dealing with. So these centipedes, where are we likely to find them? Well, we're likely to find them in dark, damp, moist conditions. So that's sort of under bricks that you might have, or concrete slabs provide these conditions. If you've got any of those in your garden, if you lift those up very, very carefully, you might get quite lucky and see centipedes like this. And the reason they like those conditions is simply because they eat things like dead and decaying wood. And that's the best conditions for wood to break down and decay and start to go a bit moldy in. So it's a really good area for these types of centipedes to find the food that they like to eat. There were also, one final fact about centipedes before we move on to the next one, is that they're one of the oldest species ever discovered. So the centipede dates back as a species to about 430 million years ago. And that is an awfully long time. And to put that into perspective, the dinosaurs went extinct 65 million years ago. So these centipedes have seen quite a lot. Although it won't be one individual centipede that lived for that long, it will be a generation that's passed on and passed on and passed on, because centipedes themselves only live for about 2 to 5 years in the wild. So that's centipedes. That's the first arthropod, this group of insects and group of arachnids also fit under this, and we'll talk about a bit later. But this one is actually called a myropod, and it fits in the arthropod group, or arthropod grouping. So the next one we're going to be looking at is ladybirds. So ladybirds are a little bit smaller than those centipedes. They tend to be 0.3 to about 0.7 inches long, so a bit smaller. They don't really like the dark, dingy environments that centipedes like. They prefer leafy and green environments, like you can see this one on here. One of the reasons for that is because they eat a species of bug called aphids. And aphids eat leaves. So of course, if you're going to find aphids on the leaves, you're going to find ladybirds on the leaves as well. If there's a lack of aphids in a certain area, one interesting thing about ladybirds is that they have been known to eat members of their own species, and they're one of the only species that will actually do this. So they're almost like cannibals in that they eat their own species. They're bloodthirsty. They won't stop at anything to get their food, even if it means eating their brother, for example. So they're really, really cannibalistic, bloodthirsty animals, the ladybird, even though they look quite dainty with often they've got like this, a red body with black spots on it. They can also have an orange body with black spots or a yellow body with black spots, although in this country we tend to find them with a red body and the black spots there. You can see it's got it's got 6 legs there. They also have wings, so are able to fly, ladybirds. And their main predators are spiders, frogs, even dragonflies will eat them. So if you're trying to get ladybirds to come into your bug hotel or bug house when we're making it, you want to avoid the conditions that maybe spiders like, to get more ladybirds, to keep the spiders away and keep your ladybirds safe. So moving on to spiders. Spiders aren't a myropod like those ones. They aren't an insect like the ladybirds, but they are an arachnid. So this is a sort of a subgroup in the arthropod group. So the arthropod group involves all of these. And then in that group, we have things like myropods, which are the centipedes. We've got things like insects, which are ladybirds, and arachnids, which are the spiders here. So arachnids tend to have 3 segments of their body, like we kind of saw with this diagram here. We've got a diagram of a spider here, where we saw the 3 segments. So yeah, they've got 3 segments. They also tend to have 8 legs as well. So a bit more legs than the ladybird, but less than the centipede. The spiders themselves live in drier conditions, anywhere where they can make their web. And spiders are interesting and sort of unique animals in that they can produce silk to make a web from. And silk is made up of the proteins that they eat. So they eat things like flies and break down the protein in the fly, which is a building block that can build up things like the silk that the spider is making its web out of. They build up the silk and they produce it and sort of spin it into this web-like fashion. It's very, very strong. So as their prey, as the things they want to eat are flying by, they don't see the silk because it's very thin, and they get caught in the web. The spider will then come and wrap its prey, wrap the fly in the silk, get it up in a tight bundle and feast on it and eat it. And then some spiders can even be poisonous, and use that poison to paralyze their prey before they eat it, just so it doesn't struggle and doesn't escape. Now, spiders in this country tend not to be poisonous. Again, it tends to be in rainforest situations where we get these more poisonous animals as well. Yeah, so now we've got myropods, we've got insects, we've got arachnids, and I'm going to show you another insect. I'm going to slightly move out the way of this one. This one here, we've got the bee. So the bee is another example of an insect. You will know a lot about bees already, presumably. They prefer habitats that contain a lot of flowers. Now, one thing that you might not know about a bee is they're probably one of the best animals at teamwork out there. So that over 40,000 worker bees can live in one hive and one area. And what they do, is they create honey. But the way they create honey is they go from flower to flower to flower, and they collect a thing called nectar. And nectar is what they then use to make the honey. And bees actually have a special nectar pouch in them, so sort of as a body part that they can store the nectar in from between 50 to 100 flowers before they have to fly back to the hive and drop it off and go and start again. Now, when they get back to the hive, if they found a particular area that is really nectar rich and is really good for collecting nectar, they'll communicate with the other 40,000 bees in there. And then they'll actually do a special communication dance, which you can look out for now, you know, and you'll see them doing it quite a lot, where they fly in a figure of 8. And in the middle of that figure of 8, so at this point, they do a bit of a wriggle. So it's a kind of a figure of 8 and a bit of a wriggle in the middle. And that means they found a good source of nectar. It's sort of saying to the other bees, follow me. I've found this really good source of nectar. If we go, we can all get loads of nectar and make a lot of honey for our hive. So they're really, really good at teamwork. And another example of how they're good at teamwork is they will stop at nothing to defend their team, to defend their hive. So for example, if you're an animal that's attacking their hive, trying to get the honey out of the hive, the bees will sting you, as you know. And there's nothing really to be scared of a bee if we see it in the garden, because it doesn't want to sting us. Because when it does sting us, it dies instantly. And the reason for that is its tail almost has like a barbed wire effect. So when it stings the skin of us, or the fur of an animal, the stinger actually stays stuck in the skin. And as they fly away, it gets pulled off of the bee, and also pulls off a section of its digestive system and a section of its nervous system, and that kills the bee instantly. So by stinging you, it dies. And of course, it doesn't want to do that, but it's doing that to protect the hive as a whole. So if you ever want a really, really loyal animal friend, the bee is one of those, because it will just stop at nothing apart from death to sort of save its mates and to save the 40,000 worker bees in there. So yeah, we've got these 4 examples that we're likely to see in the garden, especially this time of year. It's just coming out of spring, moving towards summer. We're very, very likely to see these ones in our gardens. But some rarer finds that you might be able to see are these ones here. So these ones are a little bit more interesting, a little bit more unique as well. So we start up in this corner here, we've got the green shield bug. Now, it's quite difficult to see here, so imagine how difficult it is to see out in the environment. But when you're collecting leaves for your bug hotel, keep an eye out for this type of thing, because it's the color of the leaf. It kind of mimics, it camouflages itself on the leaf that it likes to eat and the leaf that it likes to live on. So it's very, very difficult for predators and things that want to eat it to be able to see it. So it's very, very good at surviving. Something that's completely the opposite of that is this garden tiger moth here. And it's called a tiger moth because it replicates the colors of a tiger, which doesn't disguise it as well, but it does. It's very, very good at attracting mates. So it's got a different use to the green shield bug in that it's got these bright colors to attract mates. Another example of quite a cool animal is these stag beetles that you can see sort of just below it. I think these are quite cool. They almost look like mini rhinoceroses because they've got huge horns at the front, or in this case, they're sort of like antlers, not antlers, sort of pincer type things at the front that make them look quite interesting as well. And one of the more beautiful ones that you might see at this time of year, especially, is the dragonfly, this side, the dragonfly here. So the dragonfly itself, if you want to see something like this, you're going to have to go to a water source, like a pond, a lake, a river, or a stream. And the reason for that is because that's their habitat. They normally buzz around and eat lots of the little insects that live in those areas. And they're very, very majestic in the way they fly. So if you're ever at a lake, a river, or stream, and you're looking out for these, you're looking for something that can almost look like it's just hovering rather than flapping its wings. And that's simply because the wings move so fast, it gives it this hovering effect. So again, 4 other more interesting arthropods that we might be able to see in our gardens or when we're on walks out and about at the moment. So They're a few of the rarer ones. But why do we need these arthropods? Like some people, especially with the spiders and the bees, a lot of people are scared of these arthropods. And there's two main reasons why we need arthropods. The first one is they're an important part of the food chain. So the food chain being the order that animals eat each other. So for example, a very, very basic food chain would be, if we look going back to the ones we just used, the centipede, which eats sort of dead wood and decaying wood. Something like a bird might eat that. Now, if we got rid of the arthropod, the centipede, from that equation, that would mean the bird would have nothing to eat, or the birds would have nothing to eat. So they would eventually die off too. Then whatever's eating those birds would die off, like a fox, for example, because it's got no birds to eat because they've died off. So by getting rid of arthropods, we can destroy whole ecosystems of animals as well. And that can come back and rebound against us. So although we're not going to eat foxes, we might eat something like chickens, and chickens can sometimes eat arthropods as well. So if we're destroying all of the, or getting rid of all the arthropods, eventually it'll get rid of all the chickens, we won't have any chickens. And you could say, oh, well, we could just eat a plant-based diet, or we could just eat fruits and vegetables. But arthropods are actually, the second reason why arthropods are useful is related to that as well. So the second reason is arthropods do a process called pollination, or carry out a process called pollination. And the bees in this example are doing it. But if we take a look, or a close look at a flower, in the center of a flower, we have pollen. So it's sort of the darker area in the middle of the flower. Now, when the bees are searching to get that nectar to bring back to their hive, they're brushing up against this pollen of one plant, and they're taking it, when they go to find another plant to get more nectar, they're taking it to that other plant. Now, what that's doing is it's allowing the plant to create seeds. And those seeds will then fall to the ground and be planted and grow into more plants. So this is important in fruits and vegetables, which of course are plants and will be pollinated by arthropods like bees. So without bees and without these arthropods, they wouldn't be able to create seeds, and we wouldn't be able to grow any of the fruits and vegetables either. So they're very, very important to us. As long as we like to eat, we're going to need arthropods and creepy crawlies. So we want to help them as much as we can. That's where we get into today's lesson, where we're going to be looking at the sort of physical aspect of today's lesson in building a bug hotel, or an arthropod palace, if you like, where we're trying to create a nice environment for these arthropods to survive, to basically say thank you to all the things that they're doing to help keep us alive. So the things that we should have or should need, and if you've not got these, don't worry, instructions will be sent out after the lesson, and you can make one at the end of the lesson, but we'll talk through it now, just so when you get to it, you know exactly what you're doing. But you'll need sort of a main structure. Now, I'm going to be making mine out of plastic bottles and cans and things like that, but you can use cardboard tubes, you can use old flower pots, and you'll be doing it in much the same way that I am now. But what you want to be doing with these plastic bottles and with these tubes is you want to just be cutting the tops off. If you've got plastic bottles, you want to be cutting the tops off of them, so that you have in fact, I've got an example down here, the bottom of the bottle like that. And what this creates is an area for your arthropods to live in and be sheltered. So they'll be sheltered from predators, they'll be sheltered from the conditions, because remembering they're cold-blooded, so they rely on their environments for their heat. So we want to create an environment that is quite warm and cozy, just in case it's cold or it's getting too cold for them to live in. So the way I've created that is I've just simply cut off the top of a bottle, and be very, very careful if you're doing this at home. You'll want to ask for an adult's help if you're younger as well, because it can be quite tricky, and sometimes, depending on the bottle, it can leave it a bit sharp at the end. Most of them will be fine, but be very, very careful otherwise. So I've done that, and I'm going to do that a total of about 4 times. So I've got about 4 examples here, and one of the ones I've used, instead of using a bottle, I've used a can. Be extra careful with a can, because it can be quite sharp on the end. To sort of stop it from being sharp, I would recommend putting a bit of tape over the sharp bit around there as well, because not only will you appreciate it when you're sticking them together, but your insects will probably appreciate it, and your arthropods will probably appreciate it too. Now, it doesn't matter too much if they're different sizes, for example, these two different sizes, but what you want to aim to do is line them up so that the tops are next to each other, and then paired them up with ones that are sort of similar size, and I'm just going to tape those two together. So that's the first step. Once you've got these ones here, you want to tape them in pairs. And the way I'm going to do that is I'm just going to get a nice long piece of tape. So, and I'm going to wrap it around my two bottles like so, just to keep them together like that. And it's starting to create a structure. Now you kind of you can do this with one or two, where you've got this smaller palace, and you can then keep building to it afterwards. But I'm going to do it with 4. I think 4 is quite a good number to start off with. So I'm going to pair another 2 together, these 2 here, and I'm going to tape all the way around those ones too. So remembering to keep the tops lined up kind of like that as well. Once you've got your 2 pairs, you then want to stick those 2 together. So we have a group of 4 like that. The way I'm going to do that is you can do it by wrapping the tape around again, or you can just tape the tops together as well, and that will help. If you've got any sharp edges, you can pop a bit of tape over it then as well. Yeah, so I'm going to just wrap this piece of tape around the 4, holding it very carefully so that I line up all of the tops together to create something that looks a little bit like this. So this is our outline, and you can see it's starting to come together a bit. Now, it's not looking particularly inviting for an arthropod at this point, because it's made of plastic. Now, woody materials, if you've got those, or cardboardy materials, are also great. They're even a little bit more inviting than this plastic to even just start you off. But the way we can improve this plastic one we've created is by adding lots of little bits of natural material. So with your natural material, you kind of want to think about what the type of arthropod you want to bring to your hotel or invite to your hotel. So for example, if you want the centipedes, if you want lots of centipedes, you're going to want to make it very dark, very muddy in there, very rocky almost in there, because they like those dark, moist conditions. Now, if you want to attract ladybirds or bees, you're going to want to make it brighter with leaves, with flowers and things like that. So I'm going to do a mix with this structure here. I'm going to pop in, I've got some flowers that I can pop into one of them. I'll put it into this one here, and hopefully that would attract some bees like that. I've got some sort of woody, dead wood material. I'm going to pop into this one that is very, very good, or going to be very good for this one. And if you've not got those materials just yet, you'll have plenty of time after the lesson to go out and get some of those, and plenty of time to add more at the end of the lesson as well. So you're just going to be popping those in there to kind of create an ideal shelter for your bugs or your creepy crawlies or whatever you want to attract. Now, I also was thinking I would quite like some ladybirds in here. So I'm looking for some leafy structures. So I've got some leaves here. Now it might take a couple more days for the ladybirds themselves to be to sort of habitat your hotel, or get inside your hotel. And the reason for that is because, like we said, they eat the aphids that are first attracted to the leaves. So you're going to need, not only are you going to need leaves, but you're going to need to leave it for a little while to let those aphids house in first. So if I start popping them in there, we've got another house that is, or another little section that's quite leafy. Finally, for my last section, I think I'm going to put a few more flowers in my last one to see if I can help out bees. Now, bees will normally try and live in the hive as a group, but occasionally a solitary bee can get lost, or a bee on its own can get lost or expelled from the group. Now, we want to make a home for that. So that's the type of bee you'd be looking to attract with this one here. one that doesn't have a hive for whatever reason. So this is what the very, very basic example I've created here. And you can keep adding things like bits of wood, bits of old felt from the top of a shed, or roofing, or tiles, or bricks, or things like that. I've got an example of a sort of bigger and a better one, and a few more to show you a bit later on. But just before we do that, what we'll do is we'll go to some questions. So if you've got any questions on any of the stuff, anything to do with the making of it, anything to do with the vertebrates, invertebrates, arthropods, anything like that, type them in the chat now, and I'll hand over to Lawrence, and Lawrence will read some of them out, and we'll hopefully get through and answer them. And then at the end, we'll come back to showing you what I made earlier, and sort of give you some ideas, or some more ideas as to how you can make yours.
Great, thank you, Jack. Marvelous journey through various different arthropods. I've learned a lot today. I hope everyone else has as well. We've had a few questions come in, so we'll make a start. If anyone thinks of others as we're chatting, and as Jack is answering these first couple, do just type them into the chat and we shall get them asked for you. So, Jack, first question. What's the most poisonous spider that you'll find in the UK?
Oh, the most poisonous spider you'll find in the UK. Oh, so a lot of spiders do have poisons in them. We call them more venoms, because they use the venom to paralyze the flies. So in the UK, most spiders, not all spiders, but most spiders will have some sort of a venom. It won't be enough venom to harm a human or for a human to feel it, but it will be enough to for a small bug, like an insect, like a fly or something like that, to feel it. So that's as dangerous and as harmful as they get in the UK. Nothing to harm a human, but enough to harm a bug.
Great, thank you. And what's the difference between a centipede and a millipede?
Good question. Yeah, so the difference between a centipede and a millipede is centipedes, like we were saying, they tend to have, per segment, tend to have 2 legs, one on each side of the segment. Millipedes tend to have 4 legs in each segment, so 2 on each side. So that's one big difference. Another big difference is that millipedes, when attacked, will be able to roll themselves into a ball as a form of protection. Centipedes don't do this, so that's another good way to tell the difference between a millipede and a centipede.
Great, thank you. I've had a couple of other questions online. So the first is, how come queen bees are so big?
Good question. Yeah, so queen bees are so big. They're actually a different sort of type of bee to the worker bees that we were talking about before, and their purpose is slightly different to the worker bees. Queen bees don't go out and collect nectar. What they do is they lay eggs, and they actually lay about 2,000 per day. And can lay up to sort of 200,000 per season, per year, but it will be in a certain time of that year. So their purpose is slightly different. So their bodies and their body structure is built differently to suit that purpose a little bit more, rather than going out and flying around. They don't need to do that so much. They tend to just stay put in the hive.
Great. And a related question to that is, what's the difference between a normal bee and a bumblebee?
Good question. So a bumblebee is just a species of bee. Now, it's kind of like how you would say, we could call dogs dogs, but you can have different species of dogs or different types of dog. Like you can have a Labrador, for example, and a poodle. They're very, very different. Well, they're very, very similar in certain ways. They both have dog-like features, and you could look at it and say that's a dog. But they have different features. Like a poodle has curlier hair, longer fur, tends to have more of a smaller head than a Labrador. With bees, it's the same. So a bumblebee tends to be a species of bee that's a bit bigger and a bit larger than what you would say is just sort of your normal garden other type of bee. They're the smaller ones that you might see, but they have a lot of similarities. They're both bees, yellow and black. They both have a stinger. They both have 6 legs. They both have wings. There's lots of similarities, but just slight differences.
Okay, great. And a question from Anna. Why do spiders like bathrooms so much?
Good question. Good question. Yeah, it normally tends to be so the spiders that live in houses, house spiders. A lot of them like dry conditions. Now, the bathroom you don't think of necessarily as being dry, but what you do have in most bathrooms is a fan or an extractor fan. So that's where they tend to live. It provides sort of airflow through there, so they can get through that air vent and they tend to hang around near there. So not only is it a point of entry for the spider, but also once they're inside, compared to the outside, it's a lot drier and a lot better conditions for them to spin a web and sort of live in. But spiders in the house are actually not a bad thing. They're quite a good thing because they keep away things like flies, which are more annoying than spiders, even though spiders are a bit creepy or can be seen to be a bit creepy.
Great, excellent, thank you. And Sunny from Brighton says hi and asks, how do insects breathe?
How do insects breathe? Oh, good question. So a lot of insects will have, instead of breathing through their mouths like we do, they'll have tiny holes on the sort of on the outside of their bodies. These holes are called spores. Now these spores will constantly be taking in air, and then the insect will use the oxygen from the air and release carbon dioxide from these spores. So it's not through their mouths, it's through tiny holes in their bodies.
Brilliant, fantastic. That timing is brilliant because we've just got to the end of our last question, and I think we're going to go back to Jack now, who's going to show us how you can develop your bug house even further.
Fantastic. So if one that I've made earlier, or an example I've made earlier, we can see something like this one here. So this one's a bit more of an extreme example to our plastic bottles, but it's still following the same basic structure. So it's still following the fact that we've got these, if you look really carefully, I've got tubes in there, I've got some boxes below, and I've sort of stuck them all together using tape, using glue, and I've stuffed it with things like flowers, leaves, and down here we've got some more rocky areas. So once you pop this in a garden, you'd expect to get sort of some creatures or some arthropods coming towards it. I've also, on the top of this one, I've put a bit of a protective covering that you might find on the top of a shed. It's the same sort of material like a shed felt, sorry, that makes it more waterproof. So it'll mean that the cardboard I've made out of it will last a little bit longer. I've kind of doubled this one up as well. And on the other side, I put in some other bits. So you can kind of do it double-sided, and at the bottom I've got some shredded paper, some more leaves, some more flowers in that one there. If you're feeling particularly adventurous, you can create sort of like your own arthropod palace, like we've got here. And this is really, whoever made this has got more time than I have to make it, but they've got plenty of layers in there and things like bricks in there, lots of grass on the top as well. So it's providing a really, really royal home, it almost looks like, for your arthropods, with lots of little different conditions in there. So you should get lots of different types of arthropod in something like this. So hopefully that's inspired you to make your own. If you do make your own and do go away and make your own, let us know how it gets on. Let us know what it looks like by sending us a picture. Let us know where you put it in your garden. So you want to put it somewhere, if parents are listening, you want to put it somewhere that's far away from the house. But realistically, what you want to do is you want to find an area, say if you want centipedes, you want to find the ideal area where you're going to find centipedes anyway. So that would be a dark, moist area, maybe at the bottom of the garden behind the shed. If you want ladybirds, bees, something like that, you might put it below a bush or something like that. So you've got to think really, really carefully. So let us know how yours gets on, where you put it, and then you can even keep like a guest list of every bug, every arthropod that visits your palace, your hotel, your whatever you decide to call it, and let us know what you found in your garden too. So thank you very, very much for joining me today. I hope that I wish you all the success in making your arthropod palaces, your bug hotels, and certainly let us know how you get on.
Brilliant, thank you very much, Jack. Thank you everyone for tuning in, and especially for those of you who asked such great questions of Jack towards the end of the lesson. Jack mentioned a couple of really good follow-up activities and extensions you can do. We'll send out an email with the instructions on building your bug house and some ideas for things you might do to sort of extend your learning after this lesson. Loads of natural historians, so people who study nature, before the invention of photography, would draw all the animals they found. So you could use your artistic skills and draw some of the animals that you find in your garden and send us pictures of those as well. So thank you all very much for coming. Feel free to unmute yourselves in a moment and say hi and bye to Jack. If you're around tomorrow, we have a fantastic lesson with our tutor Sadie, who is our resident spy expert, and she is running Spy School. She is going to be teaching about various different codes and how you can break them, Morse code and binary code, and also looking at invisible ink letters that were written to hide messages, secret messages. So do join in. There's an email coming out about that. It's 3:30 tomorrow, and we'll send a link half an hour beforehand. So thank you all very much, and bye for now.